Hey guys, Mr. Gran, 13.4 inverse trig functions. So now we're going to be using the unit circle backwards, right? Instead of doing sine of 30, we're going to do inverse sine of 1/2. If you have your unit circle filled out, you've been practicing, you're good with what we've been doing so far, this isn't a big leap forward. It's just doing things backwards. So objective today, using the unit circle to evaluate the inverses of trig functions. Now, a couple things about that. First off, when we're evaluating with inverse trig functions, we're finding angles which have a specific trig ratio. So like I said, instead of saying what is sine of 30 degrees, we're saying what angle has a sine ratio of 1/2. So we're doing it backwards. This is using the unit circle backwards. That's why I put that in there. All right, so what you're actually going to do is find the trig ratio on the outside of the unit circle in either the xy coordinates or where you wrote all the tangent ratios. And the answer is the angle on the inside. So before we were saying, what sine of 30 degrees? You would say, okay, sine is the y value at 30 degrees, and you're taking the y value as your answer. Now we're saying, what angle has a sine value of 1/2? And you would find the 1/2 on the outside and get your answer 30 degrees from the inside. So everything in math has an inverse, right? Plus has minus, multiply has divide, sine has inverse sine, trig has inverse trig. All right. Consequence of this is there are usually two answers because a lot of those numbers, they all repeat around the unit circle. Okay, so first example. Find all exact values, meaning not decimal estimations, between 0 and 360 degrees. So just what's on the unit circle, not like, all the way around to like 600 degrees or something. That's not part of this, just what's on the unit circle. For cosine inverse of root 3 over 2. Adjust that a little bit. Okay, now cosine is the x value, right? So what we're really answering is, where is x equal to root 3 over 2? That's what you should be thinking about here. X values of root 3 over 2. The x value is the first value in the coordinate. I have one right here. I also have one down here. So there's two answers here. One of them is at 30 degrees. And one of them is at 330 degrees. So this is 30 and 330 degrees. Both of those, if you said, what is sine of 30, or cosine of 30, excuse me, it would be root 3 over 2. Cosine of 330 would be root 3 over 2. So those are two answers for inverse cosine. All right, next one. Sine inverse of negative 1/2. Sine is the y value, so the question we are asking is, where is the y value, negative 1/2, from the unit circle? All right, negative 1/2 for the y value. The y is the second one in the parenthesis, right here, and then all the way across over here at negative 1/2. So I've got two answers again, 210 and 330. Doesn't matter what order you put them in, I just always do things in numerical or alphabetical order. All right, now I got to make a little change on this one. This is a rationalized tangent number, tangent ratio, and we decided not to do rationalizing because we're doing virtual learning. So this should be 1 over root 3. That's how I wrote it on my video when we went through the tangent ratios. Okay, so now with this one, what we're saying is, where is tangent equal to 1 over root 3? So if you look at those tangent ratios, you should have 1 over root 3 in a couple of places. You should have a positive 1 over root 3 right here at 30 degrees. And you should have another one over here at 210 degrees. So that one's going to be 30 and 210. All right, next one. cosine inverse of 3. Now cosine, again, is the x value, so we're asking where is x equal to 3 on the unit circle? Well, does x equal 3 ever on the unit circle? X is equal to 1 right here, so 3 would be somewhere way over here off camera. So the answer is that it doesn't. So inverse cosine of 3 is undefined. That one actually, if you did plug it into your calculator, it would give you the right answer because it would give you an error. All right, go ahead and pause and try a few of these on your own. And when you're ready, just take a look at them. And pay attention to this one down here because there's a little trick with this. All right, so cosine. Cosine is x. Where is x equal to negative 1/2? Two places, right here at 120 and right here at 240. So that would be 120 and 240. And I'm only writing it like that so it fits. All right, tangent ratio of +1. If you look at your tangent ratios on your unit circle, you should have a +1 right over here at 45 degrees. You should also have a +1 over here at 225 degrees. So that is 45, oops, not 45 over 225, 45 and 225. All right, sine inverse of root 2 over 2. Sine is the y value. So where is the y value root 2 over 2? Two places. Right there at 45. Also over here at 135. So 45 degrees and 135 degrees. Sine of 0. Sine is the y value. Where is the y value equal to 0? The only place the y value is equal to 0 would be here and also over here, the only two places. So 0 and 180. So 0 degrees, 180. Now you can put 360. Usually when we say between 0 and 360, it doesn't include 360. It's everything like, it's really 0 to 359.9999999. So this would suffice for that. All right, last one. Tangent inverse of undefined. Now this is one where students often make a mistake because they think, all right, if I look at my unit circle, undefined is right here and right here, right? These are the spots where it's 1 divided by 0 and -1 divided by 0, so it's undefined. And so they answer 90 and 270, and that's good logic. There's nothing, like, it's not a bad idea to try to do it that way. However, the trick is, can you actually plug in undefined for tangent, right? You can't plug undefined into your calculator. You can't evaluate undefined. We don't know what undefined is. Sure, it's undefined here and here, but it could be undefined anywhere else too. Like there's an infinite number of places. Like we don't know. There could be points way out outside of the unit circle that are also undefined that we're just not sure about. So for this, it is also undefined. All right, and I think that is there one more on here? Nope, that's it. So yeah, take a look at whatever the homework that your teacher assigned and let us know if you have any questions on this stuff.